What is the shape of the universe? Hi, my name is Dr. Mark Popinchalk. I'm an astronomer at the American Museum of Natural History and a planetarium presenter at the Hayden Planetarium. Today, I want to take you on a short 5-minute or so long planetarium show, asking the question, what is the shape of the universe, and looking at some of the historical answers to that. The planetarium software I'm using is called OpenSpace, and not an ad, you can download it for free right now at openspaceproject.com. So let's dim the lights and ask the question, what is the shape of the universe? Here we are, at the Earth. And if you want to, you can think about the universe as being everything beyond the Earth. And for 100,000 years of human existence, all we had was our eyes to look at the universe. When we did, we saw stars, bright points of light, and then some things that were moving compared to them. We called them planets. And if you looked closely at the movement of those planets, you could actually see that they were traveling in basically the same direction in the same area of the sky. And that's what you're seeing here, the orbits of those planets in our solar system. And if you notice, they're all kind of in the same plane, almost like race cars going around a racetrack. There's cars to their left and the right, but there's no cars up, above, or below. And so this disk of the solar system was understood by ancient astronomers. Now, only the last 400 years do we know that that racetrack is going around the sun. The sun's at the center of our solar system rather than the Earth. But this disk shape of the solar system was understood. It was only in the 1800s did we understand that the stars, those distant things that didn't seem to move, actually had distances relative to one another. And it was at this point, using telescopes, that we could see that our universe was more than just distant points of light, but they all had dimensions and overdensities of stars. You can pick some out with your eyes right now as we go. And mapping these stars revealed also large clouds of gas, nebula, that made us understand that our galaxy was a field of stars, billions and billions of them. So when our galaxy was essentially our universe, the shape of the galaxy looked like this. Here we're coming out to seeing the spiral structure of the Milky Way. And notice again this disc-like shape, similar to our solar system, in that all the things are orbiting around a more massive center. You'll also notice two dwarf galaxies that are orbiting around our galaxy, but it was in the 1900s that we realized our galaxy was not unique in its own. In fact, one of many. Every point of light you are going to see now is not a star, but another galaxy, with billions and billions of stars of their own. This is a specific data set that goes out to a specific distance so that we can see all of the galaxies within that distance. As you come out, your eye is already picking out overdense regions and areas, voids, with fewer galaxies or none at all. The data set is limited out to a cube, so you might see a cube shape. That's not actually the shape of the universe, that's the shape of the data. But from it, you can see these kind of tendrils that connect the clumps and move around the voids of this space. And this is the true shape of our universe. We call it the cosmic web. But we can extend this further out into the rest of the universe. And now you still see that cosmic web shape. Denser areas and sparse areas. Now you're also noticing probably the two massive dark areas to the either side. These are what we call the zone of avoidance, which sounds like maybe there's some astronomical reason for this area not having galaxies. It's just that our galaxy is in the way. We can't see through the stars in the center of the disk, and therefore we can't see onto the other side. But if we could, we would expect the same shape, this cosmic web, to be throughout. I love to see the structure here. And what you see is real. We're in an overdense region of the universe right now, but you can see other nearby ones as well. These are quasar surveys, which, although it's hard to tell here, show that same structure: overdense regions and sparse regions. But the shape of our universe is defined by what we can see. And here we see the cosmic microwave background radiation, the leftover light from the Big Bang, a fog that surrounds us. And so no matter where we are in the universe, there is a limit to how far we can see. But these slight variations in it, the red and the blues that you're seeing, we believe are responsible for all the other structures we see in the universe today. This is my first time doing a planetarium show online, so if any of the topics spark interest, please let us know in the comments so I can improve this more formal presentation side, rather than my fourth wall breaking side.